Have you ever walked on a sand dune and suddenly felt like you were standing on a giant musical instrument? Instead of silence, the sand itself seems to hum, growl, or sing, as if the desert is alive with a hidden symphony. It sounds like something out of a fantasy novel, but it's a very real phenomenon. Travelers for centuries have described dunes that roar like thunder or drone like an organ when disturbed. Imagine stepping onto what looks like an ordinary hill of sand, and instead of a soft crunch, the entire dune vibrates and lets out a deep, resonant tone. Why does sand sometimes behave like a guitar string the size of a mountain? At first glance, this seems impossible. Sand is just loose grains, right? Pile them up and they should simply collapse, not make music. Rocks don't sing when you step on them. Soil doesn't hum. So what's so special about sand dunes that they can turn into natural instruments? To answer this, we need to look closer, not at the dune as a whole, but at the billions of grains that make it up. Because the secret of the desert's voice lies not in the silence of a single grain, but in the orchestra they create when they move together. Here's the key paradox. A single grain of sand makes no sound when it slides. But when millions of grains begin to move in sync, they can generate a powerful vibration that spreads through the dune like a wave of sound. It's similar to how one violin is quiet, but 100 violins playing the same note can fill a concert hall. This is the first mental shift to make. Dunes sing not because of individual grains, but because the grains can synchronize, like a choir. But why do they synchronize at all? Why doesn't the motion stay random like shaking a jar of sugar? The answer begins with a physical process called avalanche. When the surface of a dune becomes unstable, maybe you slide down it or a gust of wind pushes the top layer, the grains cascade down the slope. Normally we think of this as chaotic, but in certain dunes under the right conditions, the grains don't just tumble randomly. Instead, they fall in rhythm, colliding and bouncing at just the right frequency to amplify a collective sound. It's as if the sand organizes itself into a drumbeat. Once a few grains start vibrating at the same rate, they pull their neighbors into the same rhythm, and suddenly, the entire slope begins to sing. Here's a useful analogy. Imagine a crowd clapping after a concert. At first, everyone claps out of sync. It sounds messy, like static noise, but slowly people adjust their timing until the entire audience is clapping in unison. The sound becomes louder, sharper, and more powerful. That's exactly what happens inside a singing dune. The grains are the clapping hands, and the avalanche is the concert hall moment that brings them together. What starts as random motion suddenly locks into harmony. But harmony needs more than just timing. It needs the right instrument. Not every dune in the world sings. The ones that do have a very specific recipe. The grains must be dry, clean, and round. If they're too irregular, too wet, or mixed with dust, the vibrations die out. Think of it like trying to play a piano with broken strings. You can press the keys, but no sound comes out. Singing dunes are rare because only in certain deserts, like the Sahara, the Gobi, or parts of Nevada, do you find sand grains polished by centuries of wind until they become perfect little spheres that can roll and collide smoothly. These grains act like the polished strings of an instrument, tuned to resonate. Now let's dive deeper into the physics of the sound itself. The tones you hear from a dune aren't random. They typically fall between 60 and 110 Hz, which is about the same range as a low male voice or the note of a bass guitar. Some dunes hum at higher pitches, almost like flutes. What controls the pitch? The size of the grains. Larger grains vibrate more slowly, producing deeper tones, while smaller grains create higher-pitched sounds. In other words, each dune is tuned by nature according to the size of its sand grains, like a giant set of natural instruments scattered across the planet. If you could collect sand from different deserts and pour them down a slope, you'd be playing a scale made entirely of sand. Let's pause for a moment and picture this visually. You're standing at the base of a massive dune. You run up, leap, and slide down the side. As your feet push the sand into motion, the dune begins to roar like a didgeridoo. The sound vibrates through your chest. The desert is no longer silent, it's singing back to you. This is one of those experiences where science feels like magic, but it's not magic. It's resonance, friction, and synchronization. It's physics hidden in plain sight. Here's where things get even more fascinating. Scientists have tried to recreate the singing dune effect in the lab. They build boxes of sand and tilt them until avalanches occur. What they found is that if you have the right kind of sand, you don't need a whole desert. Even a small container of sand can produce the same booming sound. This proves the sound doesn't come from the size of the dune itself, but from the collective motion of the grains. The dune just acts as a giant amplifier, making the sound strong enough for us to hear at a distance. Without the dune, the vibration is still there. It's just too faint for our ears. So let's connect this back to music. A violin string doesn't sing just because you pluck it. It sings because the vibration resonates with the wooden body of the instrument, which amplifies the sound. Sand grains are like the string, and the dune is like the wooden body. Together, they make the desert into an enormous natural instrument, and like all instruments, dunes need the right tuning. Wet sand, irregular grains, or the wrong slope will silence the song. But when conditions align, the desert becomes a concert hall. Of course, people living near these dunes have known this for centuries. Marco Polo wrote about dunes that sounded like drums. In North Africa, locals call them the booming dunes. In China, they're known as the singing sands. The sounds were often described as mystical, even supernatural. Imagine being a traveler hundreds of years ago, hearing the desert rumble as if giants were whispering beneath the earth. Without science to explain it, it must have felt like the land itself had a voice. Today, with physics on our side, we know it's not magic, but the awe remains. In fact, understanding how it works makes it even more amazing. But there's one more twist to this story. Scientists have discovered that the singing dunes don't just produce one uniform tone. Sometimes they can create beats, harmonics, or even multiple notes at once, depending on how the avalanche spreads across the surface. It's as if the dune can play chords instead of a single note. The sound is alive, shifting, and unpredictable, just like human music. In a strange way, dunes are improvising musicians, responding to the forces of wind, footsteps, and gravity with their own haunting melodies. All of this builds to a single realization. A dune is not just a pile of sand. It's a self-organizing system, where billions of tiny particles create something larger than themselves. Sound that can shake the air and echo across the desert. It's nature showing us once again that complexity and beauty often arise from the simplest ingredients: sand, wind, and motion. That's all it takes to make the desert sing. Here's the part that truly makes the story of singing dunes mind-blowing. The sound you hear isn't just noise, it's actually a record of the invisible physics happening beneath your feet. When grains slide down, they don't just rub past each other randomly. They strike, bounce, and slip in a way that produces a consistent frequency. And the dune acts as a filter, letting only certain vibrations grow louder. That's why the sound isn't a chaotic mess of noise, but a deep, pure tone. It's the same principle as a guitar string. Out of infinite possible vibrations, only a few fit perfectly with the system, and those few become music. Now think about this. Dunes can keep singing long after you've stopped moving. Sometimes you slide once and the sound continues to boom for a full minute. How is that possible? The avalanche sets off a chain reaction. Once enough grains lock into rhythm, they continue to pull their neighbors into the same cycle, like dominoes falling in perfect sequence. Your single step can set an entire slope vibrating. It's like striking a bell. One tap and the resonance lives on. The dune is a bell made not of metal but of billions of sand grains ringing across the desert. This phenomenon has fascinated scientists for decades. In fact, researchers once camped out on famous singing dunes with microphones, seismometers, and even high-speed cameras to capture every grain in action. What they discovered is that the sound comes from a very shallow layer, just a few centimeters thick. Most of the dune doesn't move at all. Instead, it's like the surface is the vibrating skin of a drum, while the rest of the dune is the hollow body that amplifies the sound. That's why you don't need the entire dune to collapse for the singing to start. Just a thin layer slipping in sync is enough to make the desert roar. But here's where the analogy gets even better. You know how in music, an orchestra can tune itself so that dozens of instruments create harmony instead of noise? Sand dunes do the same thing. Every grain has its own size, shape, and motion, but together they settle into a common rhythm. In physics, this is called synchronization, and it shows up everywhere in nature. Fireflies flashing in unison, pendulums swinging together, even human applause aligning into a steady beat. Singing dunes are another chapter in this universal story. When enough simple systems interact, order emerges from chaos. And this order isn't just interesting, it's useful. Because dunes always sing at frequencies tied to grain size, scientists can actually study the sound to learn about the sand itself. Recordings from deserts can reveal grain distributions, dune histories, even wind patterns that shape the sand. In other words, the desert isn't just a landscape. It's an archive that speaks if you know how to listen. That strange hum under your feet carries information about centuries of wind and weather. Now imagine using this principle outside of deserts. Engineers study singing dunes to better understand friction and granular flows, things that matter in fields like civil engineering, geology, and even space exploration. On Mars, for example, dunes dominate the landscape, and the physics is the same, grains moving, colliding, and possibly producing sound. So the next time we send astronauts to Mars, they might hear its dunes sing, the voice of another planet. That's not just science fiction, it's physics waiting to reveal itself. Let's circle back to the human experience. Travelers describe standing on a dune while it sings as deeply unsettling. The ground shakes, the air vibrates. Your chest resonates with the same low frequency. It feels like the earth itself is alive. No wonder ancient cultures gave dunes spiritual meaning. When the desert sings, it feels like nature is speaking directly to you. And in a way, it is. Because what you're hearing is not just sound, it's the invisible rules of matter turned into music. Friction, resonance, synchronization. These aren't abstract concepts anymore. They're right under your feet, humming like a giant natural speaker. And here comes the real eureka moment. The desert teaches us that music doesn't only belong to humans. It doesn't require instruments or intention or culture. Music can emerge wherever nature finds a way to synchronize vibrations. A dune is a choir of grains. A storm is percussion. The world is full of instruments that we usually ignore. Science just gives us the ears to finally hear them. Once you realize this, every step in the desert becomes extraordinary. You're not just walking on sand, you're walking on the edge of a natural symphony. So, the next time you picture a dune, don't see a silent pile of sand. See it as a massive hidden instrument. Imagine the grains polished by centuries of wind, waiting for the moment when a breeze or a footstep sets them into motion. Imagine the rumble spreading, the air vibrating, the earth itself beginning to sing. And realize that what you're hearing is one of the strangest, most beautiful voices of our planet. A voice born not from life but from physics itself. And that's the true magic of science. It takes something ordinary, sand, the most boring substance you can imagine, and shows you that it can become extraordinary. It gives you the key to unlock the hidden symphony inside the desert. If this journey gave you that spark of awe, then you're in the right place. Because here on How It Actually Works, we turn mysteries into clarity and show how the simplest things can hold the biggest surprises. So press like, share this with a friend who loves to travel or dream about deserts, and subscribe to How It Actually Works. Because every video is another key to curiosity, and once you collect enough keys, the whole hidden music of the world starts to play.